Good day, everyone. Welcome back to the YouTube channel. And in this second lesson of Euclidean geometry, we'll be dissecting properties of quadrilaterals. In the first video, we already spoke about introduction to Euclidean geometry. We spoke about supplementary angles, where we spoke about parallel lines, triangles. And if you haven't watched that video, please go watch that video before you start with this one. But yeah, for this video, let's get straight into it. Okay, so the first quadrilateral that we're going to be speaking about is a parallelogram. Okay, so what are some of the properties of a parallelogram? Okay, so the first thing that we kind of realized about a parallelogram is that not all sides are equal. Okay, so not all sides are equal. The only sides that are equal are the opposite sides. So let me try to use a different color for that. So they are the opposite sides. So meaning that this one is equal to this one and this one is equal to this one. That's the first thing. The second property that we know about a parallelogram, or we can deduce from what we see, which is wrong in math, obviously, to use your eyes every single time to kind of make a deduction. But in this case, we already know the properties. So the second property is that the very same pairs of equal sides are also parallel. The very same pairs are also parallel. That's why it's basically called a parallelogram, because it has two pairs of of parallel sides, basically. So it has two pairs of parallel sides. Okay, so the first property as well mentioned, it has two pairs of equal sides. So let me just fix that. Two pairs of equal side. Okay, so another property that we can deduce about a parallelogram is that the opposite angles, this angle and this angle, are equal. Okay, so meaning that as well, this angle here and this angle are equal. Okay, so it also has two pairs of equal angles. So from our eyes, we can see that all those angles are not 90 degrees. If everything or all the angles were 90 degrees, then this parallelogram would be known as a rectangle. But because the corner angles obviously are not equal, are not 90 degrees, it's kind of skewed. So it doesn't make it a rectangle, it makes it a parallelogram. Okay, so the final property that I really want us to speak about is that the diagonals of a parallelogram, so meaning if I draw a straight line like this and I draw another straight line like this that goes there, those two diagonals bisect each other. And by bisecting, we mean that they cut each other into two equal halves, right? So meaning that now this side, meaning from this point here, let me just use a different color. From this point here up until this point here, that point, that side is also equal to from that point to this point. So these two sides are equal, basically. These two sides are equal. Okay, so the reason they're equal is obviously because they're bisected, or they're cut into half by the other diagonal. So that's what bisecting basically means. It means you cut a line into two equal halves. Okay, so another part of it is that these two as well, the other diagonal is also bisected, meaning that it cuts it into two equal halves. So that's what they mean when they say the diagonals of a parallelogram bisect each other. It means that they cut each other into two equal halves. So those are basically all the properties of a parallelogram. So I'm just going to write the final diagonals bisect each other. Okay, yeah. So those are all the properties of a parallelogram. So now we're going to move on to the next shape. Okay, so the second shape I want us to talk about is a rectangle. Okay, so what I've already done is basically label all the properties of a rectangle that are kind of the same as the parallelogram. So what we know is that not all sides are equal, firstly. So we know that two pairs, it has two pairs of equal opposite sides, meaning that this side here is obviously equal to that one, and obviously this one is equal to that one. Okay, and same applies to the parallel part of it. It means that this side is parallel to this side, and this side is obviously parallel to this. Okay, so the about the diagonals, the diagonals do bisect each other, but because with the rectangle, the angle or the corner angles are all 90 degrees. It's a bit straight, so what it does is that it makes the diagonals equal. So both diagonals are equal. So when they do dissect each other or bisect each other, they bisect each other equally, meaning that all the sides or the bisected sides of the parallel of the diagonals, they are all equal, meaning that all the sides are equal. So outside of it having a 90 degrees, the diagonals bisect each other equally. So all the sides of the diagonals now are equal. So that's some of the special properties of a parallelogram outside of everything else that we know. Properties of a rectangle outside of everything else that we know about a parallelogram. It adds to a parallelogram. So it's kind of like a parallelogram because we know that a parallelogram is any shape that has two pairs of parallel lines. So it falls under the parallelogram family. So I can just write it down here that it is the parallelogram family. So it's part of the parallelogram family, meaning that both pairs or two pairs of opposite sides are parallel as well. So yeah, let's move on to the next shape. So I'm sorry I didn't write down all the properties by the side. Hopefully you guys are able to write them down now that I've basically kind of explained them. Okay, so the next quadrilateral that I want to talk about is a rhombus, and it's a bit unique compared to the other two, and the reason being is that all sides are equal. All sides are equal. Okay, so it still has the properties where the pairs are parallel, opposite side have parallel pairs, but another thing that's unique about them is that all the sides of a parallelogram are equal. Okay, so the diagonals, on the other hand, they are not equal. So it's like in a parallelogram, the diagonals are not equal. But another thing that we know about the diagonals of rhombus is that they bisect each other perpendicularly. They bisect each other perpendicularly, meaning that where they meet, they form a 90-degree angle. They form a 90-degree angle. So they bisect each other perpendicularly. Okay, so as well, if we look at the diagonals, they cut each other equally, meaning that these two sides will be equal and these two sides would be equal. Okay, another unique thing about them is that they bisect the corner angles. So remember, bisect is cutting something into two equal halves. So meaning that if this angle right here was 50 degrees, then each side would be 25. So as well as this one here, as well as that one, as well as the other one. This angle here is equal to this one. I'm saying that this one is equal to that one. This one here is equal to that one. And obviously this one is equal to that one. And same applies to the other two corners. So those are some of the properties of a rhombus. So it has all properties of a parallelogram. It has all the properties of a parallelogram plus we know that all sides, so all sides are equal. All sides are equal. And, or not even and, diagonals bisect each other perpendicularly. And last but not least, one thing that we know is that the diagonals bisect the interior angles or the corner angles, whatever you wish to call them. It bisects the interior angles. So meaning it cuts the angles into two equal parts or two equal angles. So those are all the properties of a parallelogram. It has all the parallel properties of a rhombus. It has all the properties of a parallelogram plus the other three properties, which is all sides are equal, diagonals bisect each other perpendicularly, meaning that they form this 90 degrees here, and the diagonals bisect the interior angles, meaning that it cuts the angles into two equal parts. Okay, so yeah, that's it when it comes to a rhombus. So the next shape that I want to, or quadrilateral that I want to talk about, is one of the most not even, I wanted to say unique, which is the wrong word obviously, since it's not the most unique, but it's the most common of them all. Okay, we see this one everywhere. Not to say that the other ones we don't see everywhere, but this one is just, yeah, if we talk about appearance, it probably takes 50% of the quadrilaterals in terms of how we see it in our lives. We see so many shapes that are square. Okay, so what are the properties of a square? So the first property is that all sides are equal. Okay, so all sides are equal. We know that the interior angles, all of them are 90 degrees. Okay, what else do we know about a square? We know that it has also two pairs of parallel sides. It has two pairs of parallel sides. And we also know that the diagonals, they bisect the corner angles, or they bisect the interior angles. But as well, the diagonals meet or bisect each other at 90 degrees. So they bisect each other at 90 degrees. Let me just make that a bit more neater. They bisect each other at 90 degrees. Okay, so they bisect the corner angles, meaning that this side is equal to that one, this one is equal to that one, this one is equal to that one, this one is equal to that one. So all the angles, when they are bisected, they are all 45, since obviously if you bisect 90, you're going to get 45. Okay, so what else do we know? We know that the diagonals bisect each other equally, meaning that this side is equal to this side is equal to that side as well. That side as well. So all sides are equal. So those are all the properties of a square. Okay, it's one of the most unique one. I don't think anyone can miss this one. If they would ask you any time of the day, what are all the properties of a square, you don't have to even think about memorizing all these properties. From what you see, I think you can kind of tell. This is the easiest one to kind of take out of all the quadrilaterals that we have. Okay, so I'm not going to write them down. Actually, let me write them down. So a square, they say that it has all properties of a rhombus plus all interior angles are 90 degrees, as well as last property that it has is that diagonals are equal in length. So all the diagonals are equal in length. So it has all the properties of a rhombus. If you don't remember all the properties of a square, you just have to think of all the properties of a rhombus, and then you just have to add that all interior angles are 90 degrees and the diagonals are equal. Okay, so those are all the properties of a square. Okay, so the next shape that I want us to talk about is a kite. Okay, when I was a kid, I used to love playing with kites. I used to love making kites. And yeah, this is one of the most interesting shapes, because I mean, many of us used to play with these objects. But what are the properties of a kite? Okay, so the first property of a kite is that it has two adjacent sides that are equal. Okay, so adjacent, a lot of people don't know what adjacent means. It just means that it has sides that lie amongst each other, basically. Sides that are lying amongst each other. So obviously that would be the lying part. So this is where they lie amongst each other. So just imagine a wall, like someone leaning against a wall. They are adjacent to the wall because they're kind of lying against the wall in a sense. I think that's the best way I can explain adjacent. So the two sides that lie amongst each other, as well as these two, obviously, they're equal. So it has two pairs of adjacent sides that are equal. So two pairs of adjacent sides that are equal. Okay, one other thing that we know about a kite is that it has the diagonals. Although they don't really look like diagonals, but they are diagonals, the diagonals bisect each other perpendicularly. They bisect each other perpendicularly, and also you have one diagonal, which is this one, which is being bisected equally. So meaning that those two will be equal right there. Okay, whereas with the other diagonal, the long one, it's not cut into two equal halves, but the other one is just cut into two equal halves. Okay, so as well, the diagonal, we only have one diagonal, which is the long one, that bisects the angle. So this angle here is equal to this angle, and this angle here is equal to this angle. So let me just quickly remove that little drawing there. So yeah, just to label all of them, we said we have two pairs of adjacent sides. That are equal. Okay. Another thing is that one pair of opposite angles. I can't really write down. I don't know why I'm struggling with these spellings. I have just too much in my mind. Are equal. One pair of opposite angles are equal. Another thing is we know that the diagonal, only one pair or one diagonal bisect each other equally, and I said it was the short one. Okay, so only one pair bisect each other equally, and obviously they also bisect the two diagonals bisect each other perpendicularly. So I'm not going to really finish writing that down, but those are all the properties of a rhombus. Sorry, not a rhombus, a kite. Those are all the properties of a kite. Okay, so we're just going to move on to our last shape now. Okay, so the last shape that we have is a trapezium. Okay, so there's only one property of a trapezium that you need to know. There's only one property that's there with a trapezium, but that property is that we only have one pair of opposite sides that are parallel. Okay, so with the other with the other ones, obviously we saw that we always have two pairs, but with trapezium we only have one parallel. Okay, with a kite, we don't really have any parallel sides. So with a kite, the only thing that you need to know about kite is that there isn't anything that's parallel about a kite. Okay, whereas with a trapezium, the only property that exists. So I realized that this thing really tried to change the shape and make them straight, so that my handwriting ended up being depicted or written in the wrong way. So I just really want to rewrite that. So we only have one pair of opposite sides, or sides, sides that are equal, that are parallel, that are parallel. There's nothing equal about a trapezium. It just has one pair sides that are parallel, and obviously those sides are these ones. So that is it from my side. I hope you guys were able to just go through the video and just remind yourself of all these properties of the quadrilaterals, because they come into play. I mean, a big chunk of Euclidean geometry is literally based off quadrilaterals, four-sided shapes. So you need to be very aware of their properties, because that comes into play. Sometimes they're just going to say a rhombus, and the moment they say a rhombus, and now you need to identify certain angles in a rhombus, you need to know all the properties of a rhombus, and that will help you identify what it is that you're probably looking for. That's why they tell you the name of the shape in many cases. So please go through all the properties of these shapes, and I'm telling you that will be one step into you mastering a Euclidean geometry, or obviously defeating this chapter, which is Euclidean geometry. So please go through this video, and yeah, that's it from my side. Please go like, share, subscribe, tell your friends about it, and join our online free lessons every Saturday at 10 a.m. So join our lessons every Saturday at 10 a.m. You can find the link in the bio. You can join our WhatsApp group where the link will be sent to those lessons. And every 10 a.m. on Saturdays, you're able to join our online lessons. And there's other stuff that's going to be sent on the group chat, including these videos that we're going to be posting on YouTube, including other content, maybe different questions with memos and stuff like that. So please go join the group chat, and yeah, you'll get as much information as you need regarding metric content. So that is it from my side. Please like, share, subscribe, and cheers.